What if gravity didn't matter? What if mountains were just suggestions? China didn't wait for permission. They built the impossible. A ship elevator that hoists 10,000-ton vessels straight into the clouds. But why? Southwest China faces a brutal reality. Rivers snake through valleys, commerce demands movement. But towering between them? Mountains that would make seasoned climbers weep. For decades, this geography wasn't just challenging, it was economically suffocating. Guizhou province, 36 million people, larger than most European nations, and completely cut off from China's roaring economy. Why? Limestone peaks erupt from the earth like nature's own fortress. Valleys plunge into darkness. Rivers twist through terrain so hostile, even modern transport couldn't crack it. Traditional locks? Useless. You'd need 20 separate chambers to climb the nearly 200-meter elevation change. That's days of waiting, days of burning fuel, days of watching profit evaporate. Trucks? They crawled along crumbling roads where landslides turned logistics into a death lottery. Rail? Prohibitively expensive for terrain this aggressive. The cost was staggering. Shipping a single container from Guizhou to Shanghai took 2 weeks. 2 weeks, and cost triple the rate of comparable routes elsewhere in China. Industries that could have thrived simply closed their doors. Foreign capital looked at the numbers and invested anywhere else. An entire province sat frozen while the rest of China accelerated. So China did something audacious. Instead of forcing ships through mountains, they decided to lift them over. Enter the Guizhou shiplift, a machine so powerful it turns 4 days of grueling transport into 2.5 hours of vertical ascent. Imagine this. A cargo ship the size of 3 basketball courts glides into a colossal steel chamber. Gates slam shut behind it. Hydraulic doors weighing 400 tons each seal the vessel inside with surgical precision. Then, the transformation begins. Water floods in. The chamber becomes a liquid cradle. The ship, the water, the entire structure, it all begins to rise. Straight up. Like the river itself decided to climb the mountain. The chamber weighs 3,000 tons empty. Add water and a fully loaded ship? That number explodes to 11,000 tons. That's lifting the weight of a small skyscraper. Every single cycle. The ship climbs higher. Higher than the Statue of Liberty. Higher than Egypt's pyramids. The world below shrinks. Rivers become threads. Villages become dots. Mountains that seemed insurmountable from the ground reveal their true scale only when you're halfway up their faces, suspended in a steel box, defying everything gravity insists should be true. When the chamber reaches the top, the forward gates open. A new world appears. A lake, where moments before there was only air. The ship glides forward like nothing extraordinary just happened. Like mountains are supposed to bow to commerce. But how does this monster actually work? How do you lift something this massive without catastrophe? 4 concrete towers anchor everything. These aren't decorative. They're drilled 70 meters into bedrock, deeper than most buildings stand tall. Each tower contains redundant systems, cables, counterweights, emergency brakes designed for scenarios engineers pray never happen. 256 steel cables guide the chamber upward. Each cable could tow a jumbo jet. Each is woven from 127 individual strands of high-tensile steel, twisted in patterns that maximize strength while minimizing weight. Laid end to end, they'd stretch over 80 kilometers. The chamber doesn't just rise on cables. It climbs along a gear rack system. Interlocking metal teeth engage with millimeter precision despite forces that would crush ordinary machinery. These teeth are forged from alloys that balance impossible hardness with enough flex to absorb vibrations that would otherwise tear the system apart. Balance becomes everything. Wind gusts hit the structure. Water sloshes inside the chamber. Distant earthquakes send tremors through the bedrock. Any one of these could spell disaster. So sensors monitor constantly, making micro-adjustments, keeping everything level within tolerances measured in fractions of millimeters. Hydraulic dampers absorb shocks. These dampers hold enough fluid to fill an Olympic pool. They're designed to handle impacts equivalent to meteor strikes. Because when you're suspending 11,000 tons in midair, there's no room for maybe. 5 separate computer systems cross-check every calculation, every second. Any disagreement between them triggers immediate safety protocols. One miscalculation and 11,000 tons slams into the structure with force that would erase everything below it. The power. Requirements? Staggering. The lift consumes enough electricity to run a small city. Though hydroelectric turbines at the dam generate most of it, backup generators stand ready. If the grid fails, they can safely lower the chamber, because failure isn't an option when you're this high up with this much weight. Every cycle takes 30 minutes. In 2.5 hours, an entire mountain range gets bypassed. The system can run 24 cycles daily. That's nearly 5 million tons of cargo annually. This isn't just impressive engineering. This is rewriting the rules of what's possible. But here's where it gets interesting. This project was never just about moving ships. It was about rewriting economic maps. For decades, Guizhou was a dead zone. Its economy strangled by the same mountains that made transport impossible. Industries couldn't compete. Trade moved at a crawl. Entire communities stayed poor while coastal regions exploded with wealth. The province ranked among China's poorest. Per capita income? Less than a third of what coastal residents earned. Now, everything changed. The Guizhou lift connects Guizhou directly to the Yangtze River, China's economic backbone. A 5 million ton freight corridor that slashes costs and accelerates trade like nothing this region has ever seen. The numbers tell the story. Shipping costs dropped 67%. 67. Industries that couldn't survive before? Now thriving. Industrial output jumped 42%. Foreign investment surged 83%. Factories opened. Technology parks appeared where subsistence farmers once struggled. Villages transformed into service hubs for the new trade corridor. Jobs multiplied, not just in shipping, maintenance, logistics, warehousing, supporting industries that bloom around functioning. Infrastructure. Tourism exploded. People travel from across the world to witness engineering that seems pulled from science fiction. A province once known for poverty now hosts export zones and advanced manufacturing. Guizhou connected to coastal markets, international shipping lanes, the full power of China's export machine. This wasn't incremental improvement, this was transformation. But here's the bigger picture, the strategic play that makes this more than just regional development. What happens when international shipping lanes close? When sanctions tighten? When ports shut down and global trade collapses? How does an export-dependent economy keep moving? That's where infrastructure like this becomes insurance. The Guizhou lift is one piece of a massive network. The Three Gorges Dam, the south to north water transfer project, thousands of kilometers of inland waterways. Together, they create an internal circulation system, one that can function even if external routes get severed. This isn't speculation. China's dual circulation policy explicitly prioritizes resilient domestic supply chains, chains that can operate independently if global systems fail. Projects like Guizhou are physical manifestations of this strategy. While the world obsesses over skyscrapers and bullet trains, it's the hidden infrastructure that might determine the future. Supply chains buried in mountains and rivers. Projects that don't photograph well, but deliver strategic value that compounds over decades. Climate adaptation adds another layer. As weather patterns destabilize, water management becomes critical. Systems like the Gupatan lift don't just move cargo. They regulate flow, prevent flooding, maintain navigability despite increasingly erratic rainfall. Extreme weather that would cripple traditional networks becomes manageable when you've engineered for worst-case scenarios. The technology itself becomes an export. Engineers who solved Gupatan's problems now consult on similar projects across Southeast Asia, Central Asia, Africa. Through Belt and Road partnerships, one impossible project generates expertise for dozens more. Knowledge compounds. Influence expands. Future versions are already under construction throughout Western provinces. Next-generation lifts promise even greater heights, faster speeds, more efficiency. The techniques refined here scale and multiply across regions that once seemed too hostile for modern commerce. The construction demanded materials that didn't exist before. Alloys forged specifically for these impossible stresses. Testing pushed components beyond failure points. Cables snapped under deliberate overstress. Hydraulic systems faced pressure spikes that would never occur naturally. Only after surviving conditions far beyond operational requirements did anything get approved. The risk? Catastrophic. One miscalculation, and a multi-thousand-ton mass crashes down, destroying everything below. The margin for error sits between non-existent and theoretical. Yet the system operates with remarkable reliability, safety redundancies worth every yuan spent. So was this built for efficiency or to future-proof China against global chaos? The answer appears to be both. This lift isn't just a machine, it's a chess move in a decades-long game. A statement that geographic constraints are temporary problems waiting for sufficient resources and political will. If China can pull this off, what comes next? Because while the world watches their visible megaprojects rise, it's what's happening beneath the surface, the hidden networks, that might change everything. Let us know your thoughts in the comments.